Solving systems of linear equations found in your book on page 124. Okay, first let's go ahead and let's just discuss the vocabulary here. Solving systems of linear equations. A system is more than one equation, okay? So when I talk about a system of equations, we're talking about two or more, okay? And when we're solving them, we're doing the same thing we've been solving. I'm looking for an x and a y that work in the equation, but it gets one step more complicated in that I'm looking for an x and a y that work in both equations, okay? So there are three different types of systems, okay? We're going to be dealing with systems of equations in just two. Okay, our systems are just going to have two equations up to this point. There are more. You could do a system of 3, 4, 5, 10 equations. We're going to do systems of 2 equations. Okay, so there are three different types of systems. Okay, the first type is where you have intersecting lines. If I graphed this equation, I get this line here. So every point on this line is a solution to this first equation here. Okay. When I graph the second equation, I get this line right here. So every point on this line is a solution to this second equation. So if I'm looking for the point that will work in both, I'm looking for this point of intersection here. Okay. And it looks like this is the point 3, -1. Okay, so that tells me that the point 3, -1 is probably the point that will work in both of these. So if you substitute a 3, -1 in here, that would be 3 minus 2 times -1, so that'd be 3 plus 2, which is 5, so that one works. When I put in a 3 and a -1 here, that gives me 12 minus 3, which is 9, so it works in that one too. So the point 3, -1 works in both equations. Okay. The second type of system is where you get parallel lines. So when I graph this one, I get this line here. When I graph this one, I get the second line down here. So there are no points of intersection. Okay, so there actually is no point that will work in both this equation and this equation. So when that happens, we say there is no solution when you have parallel lines. Okay, so here we had one solution. When we have parallel lines, we have no solution. And sometimes when you go to graph it, our last type of system is actually the two lines are right on top of each other, which is they're said to coincide, or they're basically the same line. So if that happens, there are an infinite number of solutions. We can't say all real numbers because not all real numbers will work in here. Like the 0.11 up here. The 0.11 won't work because it's not on the line. But there are an infinite number of solutions that will work in both. So we would just say there are infinitely many solutions. Okay? So really you're going to get one of three answers for your solutions. You'll either get a point, an ordered pair, you will get no solution, or you will say infinitely many solutions. So those are your three possible answers. Along with our three possible types of systems, there's three ways to solve them. The first way I just kind of showed you, and that's the graphical way. So graphical, you can graph it. Okay, and graphical or graphing method, okay, basically, yes, you just graph the lines and look for the point where they intersect, see if they're parallel, or see if they're the same line. Okay. The second method is what I call the addition method, and you'll see what I mean by that. The book calls it linear combination. Okay, so the book refers to it as linear combination. I will refer to it as addition. And then the last way is substitution. Okay, so we're going to look at each three of these ways. Okay, so first let's look at the graphing approach, the graphing method. We're going to solve this by the graphing method. So to solve this by the graphing method, I need to graph both equations. So here, let's color code it. I'm going to graph this 4x plus 3y equals 5. There's a couple different ways of graphing this. One is to just come up with ordered pairs, but either way I'm going to solve for y. So if I subtract the 4x, I'd have 5 minus 4x, and then divide by 3. So y equals a negative 4/3 x plus 5/3. If I solve that for y, okay. Okay, so I could graph this by using the slope and the y-intercept, but the y-intercept isn't a very nice number. So I'm going to go ahead and I'm just going to create an xy table. Okay, so I'm going to pick numbers that, let's say, are easily divisible by 3. Okay, another way of writing this, I could have written it this way: y equals 5 minus 4x all over 3. So I'm going to use my calculator to find some ordered pairs. 5 minus 4 times, let's go 0, all over 3. See if I get a whole number. Nope, I want whole numbers. So instead of 0, let's try 1. Nope. How about 2? Yep, so when I put in a 2, I get out a negative 1, so that's one ordered pair. 2, negative 1. Well, 2 worked. What about 4? Nope. 3. Nope. 5. 5, negative 5. There's another point. And let's get one more. Want to try negative 1? Negative 1, 3 worked. Okay, so we're going to graph this line. So we have the point 2, negative 1, the point 5, 1, 2, 3, 4, 5, negative 5, and then the point negative 1, 3. Okay, we connect our dots. So there's my first line. Call that my red line. Now let's do the blue line. So now we need to do, so that was just this first one. So now we need to do the second one here. Again, let's go ahead and let's solve for y. So I'm taking the 2x minus 5y equals negative 17. Let's subtract the 2x and then divide by negative 5. So negative 17 minus 2x divided by negative 5. Or I could write it as y equals 17 plus 2x all over 5 if I divide the negative out. Again, the 17 doesn't divide nice by 5, so I'm going to use my calculator to help me come up with my points to graph this. Okay, so the equation is 17 plus 2x, well, do you want to use 0? Divided by 5, so there's 17 plus 2x divided by 5. 0, no, that's not a nice number. Let's try 1. Nope. Second enter. Try 2. Nope. Second enter. Try 3. Nope. Oh geez, no numbers work nice. 4, 5. There we go. When I put in a 4, I get out a 5. Well, 4 worked. What about 8? Nope. How about negative 4? No. We can try some other negatives. Negative 1, negative 1, 3. Okay, we better get one more point just to make sure. So let's try some other negatives. Negative 2. No. Negative 3. Negative 4. I think we already tried that one. Negative 5. Negative 6. Negative 6, 1. Again, the only reason I didn't use any of the others is they're not whole numbers, and whole numbers are easier to graph. So you have the point 4, 5. 1, 2, 3, 4. Negative 1, 3. Oh goodness. Negative 6. 1. Okay. There's my 3 points. Connect the dots. Did you notice that we found our point in common? They intersect. So I'm looking for the point that will work in both of them. Well, I found it. It's right there. A lot of times you kind of have to guess, but this one I could tell it was in both tables. So my solution here is the point negative 1, 3. It's the point that will work in both of those. That's the graphing method. Okay. Okay, next we have the addition method. Okay, With the addition method, you actually add the two equations, but you want to add them. First, you might need to multiply 1 by a constant or just a number. We want to multiply so that way when you add them, something will cancel out, or one of my variables. See, if I was to add these as is, I would get 5x plus y equals 14. I would still have an x and a y. I want to add them so that something cancels. Well, if this was a negative 4x, those would cancel. So I'm going to take this first equation and multiply everything by negative 4. So I'll have negative 4x, multiply that by negative 4, that gives me plus 8y equals negative 20. So I multiplied this first equation by negative 4. I'm not going to multiply the second equation by anything. You might have to sometimes. But now, if I write one on top of the other, and we do some adding, my 4x is negative 4x plus 4x, those cancel. Negative 8y plus 3y gives me 11y, and negative 20 plus 9 gives me negative 11. Now if you notice, I just have one variable. So I can divide both sides by 11, y equals negative 1. Well, I found my y coordinate. Now I just need to find my x coordinate. So to find my x coordinate, substitute into one equation. Okay, so I'm going to substitute my negative 1 into one of these for y. It doesn't matter which one. I'm going to pick this one. So I'm taking this equation, the x minus 2y equals 5, and I'm going to replace y with negative 1. So x minus 2 times negative 1 equals 5. So that gives me x plus 2 equals 5. If I subtract 2 from both sides, x equals 3. So my solution is the ordered pair. X is 3, y is negative 1. And then it might be helpful to go ahead and double check and make sure this works in this equation. So I'm going to plug in a 3 for x minus 2 times y, which is negative 1, and make sure I get 5. It works in that one, but I have to check this one too. 4 times x is 3 plus 3 times y is negative 1, and I do get 9. So it works in both equations. So there is my solution. So there's the addition method. One more method, and that is substitution. Okay, substitution method. Okay, here's the steps. Solve one equation for one variable. It doesn't matter which one, so pick the one that's easiest to solve. Looking at these two, I see this second equation. If I just add the y over, I've solved for x. So I'm going to take this equation, and I'm going to add y to both sides. So I get x equals 9 plus y. So I've solved one equation for one variable. Now substitute into the other equation. Okay, so I'm going to substitute this into the other equation. So I'm going to take, I know x equals this right here. So I'm going to take this x and replace it what x is equal to. So I'm taking this equation, the one I haven't used yet, and I'm going to replace x with 9 plus y. So I'll have 2 times 9 plus y plus 3y equals 13. So I have to do some distributing. 18 plus 2y plus 3y equals 13. Put together like terms. 18 plus 5y equals 13. Subtract the 18 from both sides. 5y equals 13 minus 18 is negative 5. Divide both sides by 5. Y equals negative 1. Now I know what y is equal to. Now I need to find x. Well, I'm just going to plug it up here in for y, because I know x equals 9 plus y. So x is going to equal 9 plus negative 1. So x equals 8. So my solution is the ordered pair 8, negative 1. Again, let's double check it. So 2 times 8 plus 3 times -1 equals 13. Excuse me. Now 8 minus a -1 equals 9. It worked in both equations. So there is my solution. Okay. Questions? Now you might ask, how do I know which method to use? Well, whichever one is easiest for you, and certain equations make using one method or the other easiest. Okay? So one thing I will tell you, downfalls to the graphing method. A lot of times you're stuck approximating. So the graphing method isn't the most efficient. It tends to take a long time, and it's not the most accurate. So I would highly recommend you use addition or substitution. Okay, like on this first example, example 1, okay, if we look at this, I notice that this is positive y, this is negative y. So if I was just to add them as is, my y's are going to cancel. I'm left with 5x equals 15. So my y's canceled. So the addition method here is probably the easiest. Divide both sides by 5, and I already have half of my solution, x equals 3. Now I just need to plug it into one of these. Let's plug it into this one. 2x plus y equals 7. So 2 times 3 plus y equals 7. So 6 plus y equals 7. So y equals 1. So my ordered pair ends up being 3, 1. Again, we want to double check it, make sure it's right. So take 2 times 3 plus 1. I get 7. 3 times 3 minus 1, I'm just using these equations, equals 8. So there's my solution. Okay. All right. Okay. So let's go ahead and let's look at example. Let's kind of skip around a bit. Let's go to example 5. Okay. Again, just looking at these, I'm thinking the addition method would probably be the easiest, and a lot of times it is. So if we add here, and the reason I'm saying it's the easiest because I notice my y's will cancel. So I'm left with x plus x, which is 2x, equals negative plus 8 is 0. 0 is just a number, so I can still do this problem. Divide both sides by 2, x equals 0. So now if I plug a 0 into here for x, let's say x plus y equals negative 8. So it'd be 0 plus y equals negative 8. Well, then y equals negative 8. My ordered pair is 0, negative 8. Okay. Now, if you go ahead and turn the page, there are 2 your turn problems, number 1 and number 2. I also would like you to do example 6. So do that one too. Again, do example 6, your turn problems 1 and 2. Come to class ready to discuss with any questions you have. Good luck.